All right, welcome to part 2 of today's lesson. So I am now on page 22. I'm looking at problem 28 at the top of the page. So I'm going to go ahead and continue right along. It says, Timothy asks, what if two chords intersect inside a circle? Can triangles help me learn something about these chords? Look at his diagram below, in which chords AB and CD intersect or cross at point E. Part A. Timothy decided to create two triangles, triangle BED and triangle AEC. Add line segments to the diagram to create these triangles. So if we're creating triangle BED, we have to go from B to E to D and then close that triangle off. So let's draw in segment DB. To create triangle AEC, we're going from A to E to C, and same thing, we're closing it off. So let's draw in segment AC. Compare angle B and angle C. Which is bigger, and how can you tell? Likewise, compare angle D and angle A. Write your observations. So when we look at angle B is an inscribed angle because the vertex touches the circle. Right? Angle B opens up to arc DA on the top. Right? So the inscribed angle B is opening up to arc DA at the top. If you guys look at angle C is also an inscribed angle because the vertex is on the circle. And angle C is opening up to arc DA as well. Right? So you see angle C is opening up towards arc DA. From the previous lesson, there was an example with angle F, angle G, angle H, and you guys should have put in your notes that all inscribed angles that open up to the same arc are the same measure. So angle B and angle C are inscribed angles to the same arc, so that means they have to be the same. So angle B is congruent to angle C. Okay, so I'm going to go ahead and put that down in our notes. They are inscribed angles to the same arc. So this also wanted us to compare angle D and angle A. So in similar fashion, angle A is an inscribed angle, a vertex on the circle, and angle A is opening up to arc BC. Angle D is an inscribed angle, vertex is on the circle, and angle D is also opening up to arc BC. So since angle A and angle D are inscribed angles to the same arc, then that means their measures have to be the same as well. So angle A is congruent to angle D, and this is for the same reason as above. Okay, inscribed angles to the same arc have the same measure. Okay. So our triangles for part C, we want to know, how is triangle BED related to triangle AEC? Okay. So if we go back to our similarity unit in semester 1, notice that we have a pair of angles that are the same and another pair of angles that are the same. So triangle BED is similar to triangle AEC by our angle-angle similarity condition. So that means these two triangles are the same shape, but a different size, and there's a zoom factor that exists between them. Okay. If there's a zoom factor, because two shapes are similar, that means we can also use proportions or ratios to solve for missing sides. So that leads us into part D. If DE is 8 units, AE is 4 units, and EB is 6 units, then what is EC? Okay, so as always, let's mark those parts on the diagram. DE is 8, AE is 4, EB is 6, and then EC is what we want to solve for. So we're going to go ahead and label that as X. So now what we can do is set up proportions or ratios that compare the similar sides within our shape. So remember, your similarity statement tells you which sides match up with each other. So if we're looking at, let's see, BD. So we actually need to, let's go ahead back to part C for a moment. I guess this is what happens when we're winging it, guys, and we're just going through. When we set up our similarity statement and I said triangle BED, if I go to our diagram, I go from B to E to D. So this goes from my green angle to no angle to my purple angle. My other triangle needs to be in that exact same order. I need to make sure that I'm starting at the green angle, no angle, purple angle when I write that order down. So I do want us to go ahead and change that second triangle in part C. We're going to call it triangle CEA. Okay, that way we're consistent, it makes sense. And as I was trying to say for part D, the order of our similarity statement tells us all the sides that match up with one another. Okay, so I apologize for that. Again, this is kind of what happens when we're winging it, and I'm just going through notes with you guys. All right, so now if I look at the first two letters of the similarity statement, BE should match up or correspond to CE. So on the bigger triangle, I have BE is 6, and then CE is the X that we're trying to solve for. So I'm going to go ahead and set up 6 over X. All right, this is comparing the big triangle to the smaller triangle. Now I'm going to set that equal to another ratio that compares the triangles. So if we look at the second two letters, ED, and the second two letters, EA, ED corresponds to EA. So in our diagram, ED is 8, EA is 4. So we would set up 8 over 4. All right, so two fractions equal to each other, we can cross multiply to solve. So we'll do x times 8, which is 8x. 6 times 4, which is 24. And then we can divide both sides by 8. Okay, so we end up with x value of 3, which is our length of segment EC in the triangle. Something else I would like you guys to go ahead and put in your notes as a general formula when you guys have two chords that intersect each other. And I'm just going to put it in the blank space over here. All right, two chords that cross. I'm just going to draw in something similar to what we have above. All right. And then similarly, draw in our two triangles. As such. Okay, I'm going to go ahead and mark our angles the same that we had up front on the top. Blue. And then this time I'm gonna go ahead, similar to how we had X, I'm gonna label all of our distances with a variable. So I'm gonna go ahead and label this distance A, label this distance B, label this C, and label that D. Okay. So in a circle, when you guys have two chords that cross, again, this is modeling the picture that we had up here. Instead of having 8, I had C, instead of 6, A, and so on. And then we still had our inscribed angles that open up to the same chord, so those are the same. In fashion, when you guys have something like this, there is a formula that we can use instead of drawing in the triangles and setting up proportions. What this is telling us is that our product of each chord is going to be equal to each other. And remember, product means multiply. So if we multiply this chord, we're going to be multiplying A and B together. That's going to be equal to the product of the other chord, which would be C and D together. Right. So notice here, my A and my B were the 6 and the 4, and the 6 and the 4 ended up getting multiplied. Our C and the D were the 8 and the X, and the 8 and the X ended up getting multiplied together anyway. So this is going to be a formula when you have chords that intersect and how you can solve for a missing distance between those. Okay, so this is something I would star, cloud, highlight. That's going to help you guys with problems such as part A and number 29. If we're looking towards the next page as well. You guys have another couple chords that intersect with part F, and that's how I would set those up. Okay, so what I would like you guys to do is try out number 29 using what I just went over with chords, with inscribed angles, diameters, semicircles. We have that for part B. Again, you have some inscribed angles with arcs, and then the chords. So if you guys can practice those, and again, send me pictures or questions, I'll be happy to check your work and let you know if what you're doing is good. Okay? Thanks, guys, and I hope you guys are staying safe during this time. Take care.